Let me also give you the 1, 2 that I like to use. So 1 over 2 prime is 1 prime times 2 minus 1 times 2 prime over 2 squared. If you'd like to keep this order, you don't have to. So this is my 1 and this is my 2. So let's follow the rule. Y prime or dy over dx equals top function prime. How much? What is the derivative of x plus 1? 1. So this is 1. I just have to copy the second function. X cubed plus x minus 2. I reach the negative sign now. I copy the top function in parentheses. And I differentiate the denominator. What is the denominator prime equal to? Plus 1. Very good. And all I have to write is x cubed plus x minus 2, everything squared. In this particular case, I have to distribute x plus 1 and 3x squared plus 1. I have to use FOIL on that, and I have to try to simplify it a little bit. In this case, I have to. So let's distribute. So we have x cubed plus x minus 2 minus 3x cubed minus x minus 3x squared minus 1. Everything over x cubed plus x minus 2, everything squared. It's not going to be a lot, but I have to try. So the positive x with the negative x go away. And then we have negative 2x cubed minus 3x squared minus 3 over x cubed plus x minus 2 squared. Remember, we never expand denominators. Should I go back and explain something here, or is it clear? So x times 3x squared with minus in front, x times 1 with minus in front, 1 times 3x squared with minus in front, and 1 times 1 with minus in front. These two go away. In descending order now, negative 2x cubed minus 3x squared and minus 3. And that is it. You don't have to try anything else. Any questions? Any questions? Okay, I'd like to look at a couple of other problems, like suppose we are given, I'm looking at 44. Let's read it together. In 44, we are given a bunch of data, and we're asked to find h prime of 2. And I would like you to choose if you want A, B, C, or D. Let's work on 1. Let's copy. Any preference? You want to do D. Very good. So that's problem 44 on page 190. So we're basically practicing the product rule and the quotient rule. That's all we're doing right now. So we're given f of 2 equals negative 3. G of 2 equals 4. F prime of 2 equals negative 2. And G prime of 2 equals 7. The question is, find H prime of 2. And we are given in part D that H of x equals G of x over 1 plus f of x. So we're asked to find h prime of 2. So if I ask you to find f of 3, let's say we're not talking about this problem right now. I'm telling you, please find f of 3. What will you ask? Right? I can't ask you to find f of 3 if I don't give you the function. So I cannot find h prime of 2 before I find before I find? Exactly. If I don't find h prime of x, where will I know? How will I know where to plug it in? Where to plug in to? So here's our function, h of x. It's given using g and f, and they say g and f are differentiable functions. I need to find h prime. So I'm going to differentiate a product. I'm sorry, a quotient. I have function 1 at the top, and this is function 2. So it's a quotient. I know the denominator will be 1 plus f of x squared. Function 1 prime, g prime of x, multiplied by the bottom function, 1 plus f of x, minus g of x times the denominator prime. What is the derivative of the denominator? Can anyone differentiate 1 plus f of x? That's it, because 1 prime is 0. Now I have everything I need to determine h prime of 2. So can anyone dictate h prime of 2? Very good. That's all I needed. 1 plus f of 2 minus g of 2 times f prime of 2 over 1 plus f of 2, everything squared. Indeed, that's all there is to it. And now I have to plug in the numbers that I'm given. So let's plug them in. h prime of 2 equals g prime of 2 is 7. F of 2 is negative 3. So in parentheses 1 minus 3 minus g of 2, 4. F prime of 2 in parentheses negative 2 because it's a product. And then in the denominator 1 minus 3, everything squared. So 1 minus 3 is negative 2. 4 times negative 2 will be negative 14. And negative 4 times negative 2 is positive 8. And the denominator is 4. Did we get the same thing? I got negative 6 over 4, or negative 3/2. What does this mean? It means that the slope of the tangent line to the graph of h when x is 2 is exactly negative 3/2. Yes, the rate of change of the function h when x is 2 is negative 3/2. Okay. Any questions? Did we get the same thing? Yes? Okay. I would like to look also at 52, part C. And then we're going to look at one with a graph. 52 part C is y equals x squared divided by f of x. They're asking us if f is a differentiable function, find an expression for the derivative of each of the following functions. And then I would like to look at B as well. I'm going to copy it so I don't have to look at the book. So y equals f of x divided by x squared. Okay. Because this is important. I'm going to make a point here, and you'll see the difference. Okay. So y equals x squared divided by f of x means that this is our function 1 and this is our function 2. So in order to find y prime or dy over dx, the derivative of y with respect to x, I would have to use the quotient rule. Top function prime. Perfect. Multiplied by the denominator, minus the top function multiplied by the denominator prime, which is, that's it. We don't have anything else. Over f of x, everything squared. And this is it. There is nothing I can do to this. Now, I would like to look at part B. In part B, we have y equals f of x over x squared. And I'm going to ask myself, do I want to use the quotient rule or the product rule? But you can say, but this is not a product. Not yet. Now it is. I couldn't have done this with the previous one. I could, but we haven't gotten to the chain rule yet. So with this function in the denominator, I can't do it just yet. We will. Next class. Because I don't think we can get to the quotient rule today. So, but now for this one, I can. So now I find dy, y prime, or dy, the derivative of y with respect to x, using the product rule. So the first function prime is negative 2 times x2, negative 3, multiplied by f of x, and plus x to negative 2 multiplied by, that's it. When I can, and when it's easier, I will change a ratio into a product to differentiate. Okay, now I would like to look at the graph. So let's look at problem 50 on page 190. Let's say we want to determine q prime of 7. Okay, q is given to us, q of x is f of x divided by g of x, where f and g are two functions. Here's the graph. Here's f in red, and here's g in blue. So they're given q as f of x over g of x. F and g are functions whose graphs are shown. We're asked to find q prime of 7. What do I have to determine first, before I even think of q prime of 7? Exactly. If I don't have the function, how will I know? So can anyone dictate q prime? Perfect. It has to be minus for the ratio. It's minus for the product is sum. No, just squared. Yes. Good. Now I know how to get q prime of 7. What will I do is just replace x with 7. So f prime of 7 times g of 7 minus f of 7 times g prime of 7 over g of 7 and everything squared. Now I'm not given these numbers. I have to determine them. We have to determine them. Okay, let's start with f of 7 and g of 7. So here's f in red, g in blue. 7. 1, 2, 3, 4, 5, 6, 7. G of 7 is, this is 0 here. So g of 7 is 1, and f of 7 is 1, 2, 3, 4, 5. F of 7 is 5, g of 7 is 1. So this is 1, and this is 7. And this, bless you, is also 1. So now I have to find f prime of 7 and g prime of 7. Let's go back. So g prime of 7 is the slope of this line at 7 and other points as well, but at 7. So here's how I will address this. I need to determine the slope of this line at this point. I will try to form a right triangle using the corners of the grid, because this straight line has the same slope no matter where I am. So I see run of 3 and rise of 2. It's negative also. So g prime of 7 will be negative 2/3. Do we agree? Okay. So g prime of 7, this negative 2/3. Now let's look at f prime of 7. So at 7, this is the line that I have to look at. And now I see a rise of 1 and a run of 4. Because I'm using the corner of the grids. This corner, and this corner. So I see for the slope of this line. I see a run of 4 and a rise of 1 with a positive slope. So how much is f prime of 7? 1/4. Now I can put everything together and get q prime of 7. 1/4 times 1, which is 1/4. Negative with 7 and negative 2/3, these are all multiplied. So it's positive 14/3, and everything divided by 1. The least common denominator is 12. I need a 3 and I need a 4. So 3 plus, is it 56? So the answer is 59 divided by 12. So let's do this again. I have a 1/4 times 1, which is 1/4. Then I have a negative 7 times negative 2/3. Negative 7/1 times negative 2/3 is positive 14 divided by 3. And the denominator is 1, so it doesn't count. So the least common denominator is 12, but I have to multiply the top of this by 3 and the top of this by 4. So 3 plus 56 is 59. Over to, yes?
Doesn't the negative,
Yes, but I also have a negative here.
doesn't negative positive?
Yes, I did.
Okay.
So negative 7/1 times negative 2/3 is positive 14/3. Is that okay? So I have a minus and I have a minus. So then I have 7/1 times 2/3, which is 14/3. Better? Perfect. Any questions? Any questions? Okay. Let's move on to the derivatives of trig functions. 3.3. Okay. For derivatives of the trig functions, what we are trying to do here is find sine x prime, cosine x prime, tangent x prime, cotangent x prime, secant x prime, and cosecant x prime. This is what we want to find. There is a theorem, or a rule if you want, that I don't want to wait till chapter 4 for. I'd like to talk about it right now. It's extremely useful, and now we have all the information we need. It's called L'Hopital's rule. L'Hopital's rule. This brilliant mathematician showed that only in the case of a ratio, only for ratios, the limit as x approaches a from f of x over g of x can be determined as the limit as x approaches a from f prime of x over g prime of x. Let me caution you, this is not the quotient rule, has nothing to do with the quotient rule. We will never differentiate a quotient like this. So this is a rule that says that if you have the limit as x approaches a, and you have to determine from a ratio, only for ratios, you can go ahead and do this, only this time, one time, but only if there is an indeterminate case of 0 over 0 or infinity over infinity. In no other case this can be done. Only if we have 0 over 0 or infinity over infinity. So two very important conditions. We cannot use L'Hopital's rule in any case but in a ratio, and not in any case cases other than 0 over 0 or infinity over infinity. It cannot be applied if there is no ratio or these two cases, one or the other. So now, a long time ago, a month ago, even more, we looked at the limit of sine x over x as x approaches 0. And I said there is a very simple proof, but I can't show it to you just yet. How did we determine this, if you remember? Well, I know you know what it is, because we committed this to memory. What is it? 1. So what did we do to determine this limit a long, long time ago? We didn't have any tools. What did we do?
We put it in a calculator.
We graphed it. We couldn't do anything else. We looked at the graph and we said, oh, it's clear. It's 1. It does this. And it's undefined here, but we don't care, right? Okay, so please plug in 0 at the top and tell me what you get.
0.
Good. Plug in 0 at the bottom, tell me what you get. Good. Is it a ratio?
Yes.
Is it one or these two?
Yes.
I can apply L'Hopital's rule. So limit as x approaches 0. Sorry. We haven't, I jumped ahead. I didn't show you what the derivative of sine is yet. So I will show you, but for now you can trust me that the derivative of sine is cosine x. And I'll show you in a minute. Okay, so because I need it now and I don't want to have to come back. So sine prime is cosine x. What is the derivative of x? 1. So now please give me this limit. When x approaches 0 from either side, cosine approaches 1. This is a very elegant way. The rule is very powerful. We're going to use this rule moving forward for ratios and the condition one or the other, indeterminate case. Okay, sorry for jumping ahead. So now, I would like you to choose. If you'd like to see a proof, I will not ask you to memorize any of that, and I will not ask you to reproduce the proof. If you'd like to see a proof, if you say, no, I don't want to see a proof, either sine or cosine, then I will just give you the formulas. If you say, I want to see the proof of sine or cosine, then I'll let you choose, and we'll go ahead and prove it. If you don't want to see it, that's fine. It will take me about 10 minutes to show you the whole proof. If you don't want to see it, that's fine. You want to? Very good. Please choose sine or cosine. Why? Why am I not choosing these? Because all the other ones will be, yes, they're ratios of sine and cosine, and we're going to use the quotient rule for tangent, the quotient rule for cotangent. And here, it will be slightly more difficult because I need the chain rule. So please choose. I will not ask you, we want cosine? Very good. Is that what you said?
Yeah.
Okay, perfect. So this is a proof that you, if you want to write it, fine. If you don't want to write it, you don't have to. It's going to take a couple of minutes. So we have a function that is cosine x. And we do not know the formula just yet, or the differentiation rule. And we still have a way of determining the derivative. What is that way? With the definition. So if this is our function and we want to find f prime, and I remember the definition of the derivative, what will I have to write?
The limit as
Very
x
good.
approaches 0,
From,
cosine x plus h,
very good,
minus cosine x over h.
awesome. And after we are going to manipulate this in many different ways, including using a lot of trig identities, at the end of the day, right here, maybe on the next page, not right here, we're going to show what cosine prime is equal to. Okay? So here's the first identity that we have to use, which is cosine x plus h. If you remember from pre-calculus, this is cosine x, cosine h minus sine x, sine h. This is the first trig identity. It should be in the front cover or back cover of your textbook. So I will replace cosine x plus h by this. And then I will continue. So from here, I'll continue here. So this is limit, sage approaches 0, from cosine x, cosine h, minus sine x, sine h, minus cosine x, divided by h, of course. Okay, let's look at these three terms at the top. Two of them have something in common. The other one is completely off the wall.
Cosine x times cosine h and cosine x.
Perfect. I will, from these two terms, I will factor out cosine x. Limit, as sage approaches 0, cosine x, minus sine x, sine h, divided by h. What is left in parentheses? Once I factor out cosine x from these two, I have cosine h minus 1. Perfect. Okay. At this point, I have two identities that I have to use. One, I will be using it for this factor, and the other one I will be using for this. So let me show you what we're going to do next. From the formula sine, or the identity, trig identity sine 2x equals to sine x cosine x, this is another identity, front cover or back cover of your book, I will apply this procedure for sine h. So this is 2x, this is x and x. If this is h, what will this be?
H.
Over, because this is twice x and this is exactly. So this will be 2 sine h over 2 cosine h over 2. So if this becomes h, is a double angle. If this becomes h, then this must be half of this. So x is half of 2x, h over 2 must be half of h. So this will be there. Now let's see what we do with that. There is another trig identity. That is sine squared h. Let me use x to give you the formula, the identity. Sine squared x equals 1 minus cosine twice x divided by 2. Now, I do have a little problem here because I have cosine minus 1, not 1 minus cosine. But that's not a problem. I'm going to factor out negative 1. So I will have it like this. Then you're going to say, but what is with this 2 in there? I'm going to multiply both sides by 2. So I have 2 sine squared x equals 1 minus cosine twice x. I can twist this multiplying both sides by -1, which will be the same thing. So -2 sine squared x equals cosine twice x minus 1. But what I want is cosine h minus 1. What do you think I have to write on the other side? So if this was the double angle, this is the half angle. So it's half of that. If this is h, what do I have to write as sine squared of?
H over 2.
Very good. Perfect. So now I have this piece. This will replace that. And we are close. Okay? So now the limit is limit as h approaches 0 from, I replace this by this and I multiply by cosine. So it's -2 sine squared h over 2 times cosine x minus sine x times this. So I put 2 in front, sine x, sine h over 2. I always run out of room. You already know that. So let me write a little bit smaller. I'm going to cross this out. So limit as h approaches 0 from -2 sine squared h over 2 cosine x minus 2 sine x sine h over 2 cosine h over 2 over h. After all these algebraic manipulations, I see that I can factor out something here. It's definitely a -2. That's for sure. And it's also a sine h over 2. So -2 is out, sine h over 2 is out, so I do have a sine h over 2. I do have a cosine x. I do have a plus. This is out. I do have sine x and cosine h over 2. So I factor out sine h over 2 from here, and I get sine x and cosine h over 2. Last trig identity that we have to apply is this. Sine alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha, somewhere front cover, back cover of your textbook. So this is this, this is this, this is this, this is this. So then, limit as h approaches 0. Now, do you allow me to bring this here? In other words, negative h over 2. When I flip h over 2, I get 2 over h. Then I have sine h over 2. And then what is this? Sine h over 2 cosine x, sine x, cosine h over 2. So it's sine of h over 2 plus x. I'm going to write x plus h over 2 is the same thing. We're done. Okay. When h approaches 0 or h over 2 approaches 0, where does this go?
2, 1.
Perfect. So then where does this go when h or h over 2 approaches 0?
0.
Good. So finally, I'm done. The limit operator is gone. What is the answer?
Sine x. Negative sine x.
So our conclusion is that cosine x prime equals,
Negative sine x.
and then sine x prime is cosine x.
Trig Identities.
Hey, you asked for it.
I know I asked for it.
A lot of trig identities. There may be a simpler, shorter method. I never thought about it, but I just like going through these identities myself. Okay, very good. So now tangent prime. Let's find just tangent prime, and the rest I'll give you. So this is sine x over cosine x prime, and this is a ratio. We cannot differentiate the top and the bottom. That we have to apply the quotient rule, not to be confused with L'Hopital's rule. So sine prime cosine x times cosine x minus sine x times cosine x prime. I'm going to change this and put sine x over cosine x squared. But how much is sine squared plus cosine squared? This is the most important trig identity that we cannot forget.
Is that 1?
Perfect, very well. So this is cosine squared. What function is 1 over cosine? If it starts with c, it has to start with s. If this starts with c, the function has to start with secant. So from now on, we have to commit to memory that tangent prime equals secant squared. Similarly, cotangent prime equals negative cosecant squared. Secant prime equals negative secant tangent. Not negative, I'm sorry, positive, forgive me. And cosecant x is negative cosecant x cotangent x. Cosecant is with negative, not tangent, not cotangent, not secant. Okay, let's look at a couple of problems on page 197. Let's start with 12. Y equals cosine x over 1 minus sine x. This is a quotient. In order to find y prime, I have to use the quotient rule. Top function prime. Negative sine x, and I multiply by 1 minus sine x, minus the top function times the denominator prime. When I differentiate 1 minus sine x, what do I get? Sine prime is, but there is a minus, so I'm going to have to write minus cosine x over 1 minus sine x squared. So top function prime is negative sine x times the bottom minus the top times the bottom prime. I have to try to simplify this as much as possible. So y prime equals negative sine x plus sine squared plus cosine squared over 1 minus sine x squared. Again, I'm back to sine squared plus cosine squared, the most important trig identity, which is 1. So I'm going to write it appropriately as 1 minus sine x, which normally I won't do, but I peaked. Where did I peak? Yes. So I said, okay, I'm going to write in the same order so we observe something. 1 over 1 minus sine x. I remove the factor of 1 minus sine x from the top and the factor of 1 minus sine x from the denominator. Questions? Questions?
Can you side up a little bit to that?
So, is that okay? Everyone? Yes? So negative sine x times 1, negative sine x times negative sine x, negative cosine x times negative cosine x. Sine squared plus cosine squared is 1. And then I copied negative sine x. I put them in the same order so we can see that one factor from the top and one factor from the bottom goes away. Is that okay? Okay. So I think we should practice one more. Let's say 11. Same page. We have f of theta equals secant theta over 1 plus secant theta. We're asked the same question to find f prime of theta. It's a quotient, and we cannot change that. The denominator will definitely will be 1 secant theta, 1 plus secant theta squared. But now we have to determine the numerator. Secant prime is secant tangent times the denominator minus the top is secant theta. The denominator is secant prime, which is secant tangent. Let's do this one more time. So this is function 1, and this is function 2. So I have 1 prime times 2 minus 1 times 2 prime. Secant prime is secant tangent. Then I copy the denominator. Minus, I copy the numerator, and times the denominator prime. But 1 prime is 0, and secant prime is secant tangent. Does it make sense? I will try to simplify if possible. So what can I factor out? Secant tangent is in both, right? Secant theta times tangent theta. And 1 plus secant theta squared in the denominator. So, secant tangent is out, then I have 1 plus secant theta. Secant tangent is out, so I have minus secant theta. When we notice that, positive secant with negative secant. So final simplified form, secant tangent divided by 1 plus secant theta squared. I know I have only 5 minutes left. Just would like to go back to some limits. On page 198. We have looked at this problem before on 198, in which we have limit as x approaches 1 from sine x minus 1 over x squared plus x minus 2. When you plug in 1 at the top, what do you get? Which is perfect. And the denominator? Perfect. So it's a ratio. It's 0 over 0. I should be able to apply L'Hopital's rule. However, we do not know how to differentiate this. It's a function inside another function. If I had just this, I would have gone ahead to do it. But this is not the same thing. It will be the same thing in this particular case, but in general, it's not the same thing. So when I have a function of a function, this is function composition, an inner function and an outer function. So we have to wait till the next section in which we deal with the chain rule. So for now, if you remember how we did this together, we said that if x approaches 1, x minus 1 approaches 0. And then we left sine x minus 1. We had something similar on the test. And what did we do with the denominator? Once I get 0 in a polynomial, when I plug in 1, I know there is a factor of course, it must be. And the other factor will be x plus 2. Now, if I do not remember, I honestly do not remember if in your class somebody did this. But if somebody did, if you look at the test paper like this, you will see my tears. Okay? If somebody did this and wrote the answer as sine over x plus 2 or something similar, you definitely see my tears on your paper. I don't know. Maybe it was in a different class. I definitely don't remember. So we cannot simplify an argument inside a function. This is a function inside this function with a function outside. So this is like saying that f of twice x over 3x, I can simplify this x with this x. You understand? It's not possible. This is an argument inside a function, and this is something outside of it. So I'm not saying you did, but if you're ever tempted to do that, you will see my tears. I will haunt you anywhere you go. Okay, so of course disregard this. Let me erase it because it's ridiculous. So, or x minus 1 approaches 0. So this is sine x minus 1 over x minus 1 times x plus 2. So this is what we did from the very beginning. We said as long as this is the same with this and is the same with this and it goes to 0, this approaches 1, and then the result will be, and I drop the limit operator because I apply it. This is what I mean by dropping it, and the answer is 1 over 3, right? Because x approaches 1. We will be able to do this. No, I'm sorry. Okay, so one last one that I would like to look at is something like this. Limit as x approaches 0 from cosine x minus 1 over sine x. So this case is when I plug in 0 in cosine, what do I get? 1 minus 1. 0. When I plug in 0 in sine. Perfect. Now, this particular example is a ratio. It fulfills the indeterminate case 0 over 0. Ratio 0 over 0, I can apply L'Hopital's rule. So this will be limit as x approaches 0. The derivative of the top is with negative sine x, and the derivative of the bottom is very good. Now I plug in 0 again. The numerator goes to very good. The denominator goes to this is not an indeterminate case. It's not an undefined case. The answer is 0.